Now we're going to move into an example for the chain rule that has 3 layers. I'm going to do it the long way, as I've been teaching you, and then we will move into the short way. First of all, you want to make sure the derivative is easier. Whenever I made this step, I misspelled derivative. It's starting to annoy me. But anyways, can we simplify this? Well, not really, right? I mean, these are different functions altogether, so we're just going to leave it the way it is. However, we do want to look at which rules we're using, since we have a derivative inside of a derivative, a function inside of a function inside of a function. We're going to be using chain rule, and we have to take the derivative. We're going to be using power rule, because this is a numerical exponent. We're going to be using the transcendental rule of the derivative of a natural log, and we're going to be using a power rule, the constant multiple rule, because 3x. So there's the rules we're going to be using. Let's go ahead and label our components for steps 3 from outermost to innermost. F is our outermost function, because it's on the outside of these brackets. G is inside of that natural log, and then the innermost function, now we have h, is a third layer, is going to be 3x. So remember, the basic function, what do you guys and girls think that the basic function f is going to be? Remember, you're just replacing whatever's left inside of there with x, so it's going to be x to the 4th. And then inside of that, the basic function would just be natural log without the 3x, so it would just be x for g. And then the innermost function is just going to be itself, and so in this case, 3x. So now we're going to take the derivative of each of those. Derivative of this is 4x cubed using the power rule. Derivative of this is 1 over x. That's kind of a special case. It's a special log, and the derivative is just 1 over x, and the derivative of that's going to be 3 using the constant multiple rule. So there's our derivatives. Now, understanding the formula for 3 is a little complicated. It's basically like f prime of g, but instead you have 3 layers, so you have a little bit more going on. So remember, it's f prime of g of h, so f prime of whatever's left over, right, that you didn't derive, times g prime of h, the derivative of the inside layer times whatever of whatever's left over, times h prime, the derivative of the third layer. So let's write that out, f prime of g of h times g prime of h times h prime. Now we just figured out f prime to be 4x cubed. So I'm going to be replacing that x with whatever's left over in the function, namely natural log of 3x. So 4x cubed is going to become 4 times natural log of 3x cubed. Now when I do g prime of x, g prime was 1 over x, and since it's 1 over x, I'm going to be replacing x with h, so it's going to be, and remember h was 3x, so it's going to be 1 over 3x for that part of the formula. And then times the derivative of the innermost layer h, which we found to be 3, right there. So again, it's f prime of g times g prime of h times h prime. So every time there's an x in your derivative formula, you're replacing it with the inside functions, okay? And then of course the last part of it is just h prime. You're not plugging in anything for that. Then you're just going to simplify that. You can see you have a 3 up here and a 3 down there, so you're going to cancel. That's just going to become x, and you can write it as 1 fraction too. What I did was I grouped my 3 and my 3 over x. My 3 and my 3x, so that's going to become 1 over x. Then you can pull your x out front and write it as 4 over x times ln 3x cubed. And that will be it for this one, except, like I said before, I do want to show you the shortcut for this one. So let's take a look at that on the next page. Okay, so again, the way the shortcut works is you want to look at the outermost part of the function, in this case 4. Okay, then you can kind of take note of what the middle layer is going to be, which is natural log. And then finally, the inside of that is going to be 3x. So, what you're going to do, since it's a power, you can automatically see that the power is going to move to the front, and you're going to subtract 1 from what you originally started with. So you can see how that immediately takes effect. You move the 4 out front, and then you just change it to a 3. You change nothing about the inside whatsoever. Okay, so the question is, what do you do from there? Well, now you start to hone in on the second layer, which is natural log. You're going to take the derivative of natural log, and then you're going to plug in whatever's left there. So the derivative of natural log is 1 over x. So I'm just going to put a multiplication sign here. So it's going to be times 1 over x, but again, instead of x, you're replacing it with the innermost layer, so 3x. And then finally, the easiest part is just take the derivative of the innermost layer, which is 3. And so I have, when you have 3 layers, you'll have 3 things multiplied by each other. In this case, it's the outermost times the second layer times the innermost. So that's the shortcut, and then of course you would simplify it like we did before in the problem. But like I said, once you start to learn the rule, you'll learn the shortcut, and you'll see the outside and then the inside derivative, plug in whatever the third layer is times the derivative of the third layer. So if you have any other questions about this example, let me know. We're going to do a few more.